Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 8B. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 8th World Conference in Smart Trends in Systems, Security and Sustainability, WS4 2024. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through Zoom from 24th to 26th of July 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stick with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. We have with us Dr. Basant Tiwari, who is currently serving as Associate Professor, MIT WPU, Pune, India. As prior, he served as an Assistant Professor at Hawassa University Institute of Technology, Ethiopia. He did his PhD from Devi Ahilya University, Indore. He has many international and national publications to his credit in conferences and journals. He is a reviewer of various reputed international journals and books. He is a senior member of IEEE, senior member of ACM, CSI, and IAC SIT. We welcome you, sir.
Thank you, Ishita. Thank you.
I'd like to introduce you all to the next chair. We have with us Dr. Gottfried, who has 12 years of teaching experience as a lecturer in some tertiary institutions. He currently serves as an editorial board member of the International Journal of Software Engineering and Applications, IJSEA. His research interests are ITIS management, telecommunication, MIS in the organization, organizational behavior management, ISIT business strategy, ITIS project management, IT design and systems thinking, IT investments, and organizational performances. We welcome you, sir. We'll be beginning with our paper presenters. First, I'd like to invite paper presenter John Belindia with the paper titled Artificial Intelligence for Decision Making in Maritime Activities. You may start with your presentation, sir. Sir John? It seems we do not have him here. I'd go with Kusuma with the paper titled Digital Transformation, a Framework for Strategic Organizational Transformation. You may start with the presentation, sir.
Okay. Okay, firstly, I want to share my screen. Okay, is it the screen visible?
Yes, sir, it is visible.
Okay, let me start the presentation. Okay, firstly, thank you. Good afternoon, ladies and gentlemen, distinguished attendees and fellow researchers. I'm truly honored to stand before you today as we gather virtually in the World Conference on Smart Trends in System Security and Sustainability, or World S4. My name is Kusuma Anggraito, and I am here to present my research paper titled The Digital Transformation, a Framework for Strategic Organizational Transformation. Okay. Firstly, for the abstract, for the framework for strategic organizational transformation, this research presents a comprehensive framework for strategic organizational transformation in digital era, centered on the concept of DT, or digital transformation, and its implication for modern business. This framework, delineated in this paper, serves as a pragmatic guide for the organization aiming to harness digital transformation to augment competitiveness, productivity, and customer experiences. In this research, we have several research questions, as well as the first, what are the main aspects of the digital transformation? And the second, what are the key elements for every aspect of digital transformation? And the third, what are the activities driving the process of digital transformation in business? By addressing these research questions, this research aims to provide valuable insights into the intricate dynamics of digital transformation and offer practical guidance for organizations embarking on or navigating their digital transformation journey. For the theoretical literature, we have some examples of definition of digital transformation, as well as like digital transformation is an application of digital technology by enterprise to optimize business in digital world, leading to innovation, reshaping of models, and achieving success. Uh, this DT has emerged as a pivotal concept in modern business landscape, encapsulating the strategic imperative for organization to harness the power of digital technologies and to innovate and adapt of the demand of contemporary market. The next reference we refer is a Levitt diamond model created by Harold G. Levitt in 1965. Maybe if there are any mistaken spell to the name, I'm really sorry. So this model uh, is have a goal to analyze the relationship between the four main elements in the organizational system, as well as structure, task, technology, and people. By integrating this model into the framework we create, organization can achieve a more nuanced understanding of how digital transformation initiative impact various facets of the organization, as well as enabling them to anticipate challenges, mitigate risk, and also optimize outcomes. The research methodology have several stages. For the first stages is data collection. A systematic approach was applied to gather the key aspect of digital transformation. So we selecting from the first 80 papers and filtering into the 20 papers, the best one to and found the main aspect of the digital transformation. The next one are initial content analysis, aimed to determine main aspects within the concepts. After that, we do some main aspect merging to merging the main aspect with another model with critical argumentative, as well as the last model, the Levitt diamond model, and the last one, the developing the main aspects. So we develop the model to into a comprehensive framework. The research results, as well as the framework mapping, we identified 7 main aspects for the digital transformation, as well as strategy, organization, culture, value, technology, customers, and people. In the process of developing the DT framework, we considered the Levitt diamond model regarding the information systems. And for the 4 main aspect of diamond model, as well as structure, task, technology, and people, we observed that the main aspect of DT identified have a strong correlation with the 4 element in Levitt diamond model. So as we seen on the screen, there's the final model of the digital transformation framework after we found from the 20 paper and merging with the Levitt diamond model. So the first one is the structure aspect. The structure aspect divided into 2 sub aspect, as well as strategy and organization. The strategy relates to the company business strategy that needs to be aligned with DT, while organization relates to the organizational structure that support digital implementation. The next one are people aspects, divided into 2 sub-aspects, internal and external. Internal refers to the employees and the company culture that need to be changed or adapted, while external refers to the company interaction with the external ecosystem. The next one are the task aspect, divided into enabling and support. Enabling relates to tasks that support changes and innovation, while support relates to tasks that support the implementation of new technologies and processes. And the next one are technology aspect, divided into architecture and function. Architecture relates to the technological infrastructure supporting DT, while function relates to the technological application used to run business process. For culture and value, the last 2 aspects, we didn't make the sub aspect because culture and value have its own aspect. The culture aspect is a key in changing employees' mindset and behavior to support digital transformation. And the last value relates to the expected benefits from the implementation of DT for the company. Now we delve deeper into each aspect from the main model we create. This section clarified that an organizational structure encompasses the interaction, adjustment, and evolution of its various layers. The aim from this aspect is to use the organizational structure strategically for digital transformation. It involves setting goals, assessing current states, and aligning with business objectives. Structures provides a robust blueprint for organization aiming to navigate complexities of digital transformation. Oh, I forget to mention, each aspect have its own description and purposes, key elements, and lastly, the activity. So leveling from the top level is aspect to sub-aspect, and description into the lowest level are activities. And the second aspect are people aspect. The people aspect in DT aims for successful implementation and strategic goal achievement by fostering a human-centric digital environment. By addressing this aspect, the DT framework is essential for organization embarking of digital transformation journey, as well as the activities on external like digital client acquisition, partnership building, industry networking and engagement, and so on. The third aspects are task aspects. Task aspects serve to assess socio-economic impacts, study effects on organizational goals, and analyze planning criteria to address challenge. The first sub-aspects are enabling activities support digital transformation by assessing socio-economic impacts, aligning with organizational goals, and addressing legal compliance and risk. While support activities establish the framework and infrastructure for DT by aligning goals and methodologies, redefining goals, and developing IT skills among employees. The next aspects are technology. This aspect drives the fundamental industry changes, fostering disruption and innovation. It enables the adoption of digital platform and alternative business model, enhancing efficiency and sustainability. Architecture for the first sub-aspect focus on designing and implementing technological infrastructure for DT. And function activities involve assessing current technology, identifying transformational technologies, and integrating for efficiency and optimizing functionality to align with organizational objective. The culture aspects have a goal to align organizational culture with DT objective for sustainable growth in the digital age. Addressing the culture aspect within the DT framework is crucial for organization embarking on digital transformation journey. And the last are value aspects. These aspects have a goal to change operating models, change efficiency, capture competitive advantages, and impact value creation and capture. Addressing this aspect within the DT framework is essential for organization to seeking to leverage digital transformation initiative to enhance competitive productivity and customer experiences. For the conclusion for this research, we have four main points. The first one, this research emphasized the critical importance of DT for organizational competitiveness in today's business landscape. The second one, the DT framework provided serve as the structured guide, focusing on strategic alignment and organizational adaptability. By analyzing the final for 20 existing research framework, key aspects of DT were identified from setting a strategic goal to aligning with business objective. The third one, integrating the DT model with another reference like Levitt Diamond model, offers a comprehensive understanding of DT for organization beginning a digital transformation journey. This research offers a valuable insight and guidance for navigating complexities effectively. And the last, this study contribute to existing knowledge by providing a detailed framework for strategic organizational transformation in the digital age. By embracing digital transformation as a strategic imperative can lead to sustainable growth and success in an increasingly digital world. Okay, maybe that's all for me. I'm really sorry if there are any misspell or miscommunication. Next, is there any question from the audiences?
Thanks, Agregito. It was a very good presentation. I have one question for you. I want to ask about the risk. In which particular part of your framework the risk fits and how you handle the risk?
I'm sorry, doctor, can you repeat the question?
I'm just I'm just asking about the risk. In which particular part of your framework risk be handled? Because you are going to transform the organizational assets into a digital. So digital transformation is there. So risk is the very big factor whenever the digital transformation is concerned. So in which particular part of your framework risk will handle?
Okay. Okay. Thank you,
Have you
Doctor.
understood my question?
Uh, I want to make sure that your question is about risk, right? The risk how to
Yeah.
implementing
Yes.
those
Yes. Yes.
framework into the DT practice practice, right?
Yes. Yes.
Okay.
Yes. Correct.
Okay. Okay. Thank you, Doctor. So we know in implementing digital transformation for the company is very have risk. So this framework we create is more focusing about the company who wants to start its journey into digital transformation roadmap. So when uh, what the company needed, it can be achieved or it can be found in the framework. So when we know there's a lot of risks to do. So from the each aspect that I have presented, there's some activities and key aspects. So we can know the risk, maybe the risk appetite or the risk register about the all activities we can found on the main each aspect or each activity from this framework. So each activity we do from the framework is make sure to uh, settle the risk before we implement it. Maybe that's answer from me. If there are any misspell, I'm
Okay.
apologize.
Okay. Okay. Thank you. Thank you.
Okay,
If
thank you.
anybody have a question, please ask.
Yeah, maybe it's enough.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Thisara Kavinda with the paper titled Multimodal Social Interaction for Speaking Disabilities Care. So you may start with the presentation.
Yeah, let me share my screen.
Sure.
So am I audible and can you see my screen?
Yes, sir.
Cool. So good morning, everybody. I'm Thisara Kavinda from SLIT in Sri Lanka, and I'm really honored to be here in this educated audience. And I'm here to present you our research on multimodal social interaction for speaking disabilities care. So let me start my presentation. So do you know that in world there are over 360 million people who experience a significant hearing loss, and if we take at the WHO reports, it stated that 5 out of 100 people are having some sort of hearing or speaking disability. So, and in Sri Lanka also, it's over more than 389,000. So we see this as a vast problem, and you know, these people with speaking and hearing disabilities are experiencing a huge communication gap. We know that there are some digital technologies, and there are some organizations who are trying to fill this gap, but we thought that we must raise this awareness throughout the world, and we must try out how to raise the digital inclusivity in the world. So we thought of proposing a meeting platform with all the facilities, so the deaf mute people can engage with the other people without any barriers. So they can use our features in the system to communicate with the others with no hesitations. So, and the other one is we want to promote Sinhala sign language. I'll explain you. In Sri Lanka, there's low resources for the Sinhala sign language, so people are not really educated with this. So the people with hearing and speaking disabilities are really suffering from this. So when you're talking about the background, there are no end-to-end system as our research currently using in the public with these facilities. And also the existing systems do not support Sinhala or Sinhala sign language. So as you all know, Sinhala is a low resource language, so it's hard to find out the data sets and required resources for the language. And also there are publicly available data sets, lip reading data sets in the world, as LRS2, LRS3, and BBC LRW and Grid Corpus. But the case is that there are no public available datasets for Sinhala language. So, and also there are some several past lip reading researchers based on English, Chinese, and those languages. If I recall them, there's the first experiment and the first person who proposed that we can some sort of read the lips using the sequence of images of a person is Mr. Sumbi WH in 1950. And they also have the first end-to-end lip reading system was proposed by Google DeepMind team and Mr. Yanis. It uses actually spatiotemporal convolutional neural networks as well as recurrent neural networks. And for the loss, they are using connectionless temporal classification loss. So there are also several other lip reading researchers based on ShuffleNet and GhostNet also. So when you're talking about our research, in our proposed system, it contains three main components. First one is miming language to text transcription. That's the VCR model. It means visual speech recognition. And the second component is sign language to text transcript and AI assisted trainer for the single sign language. And also there's a audio to miming language model. So let me explain every component. The first one is the VSR model, visual speech recognition model. Actually, this model generates singular text transcripts based on the lip movements of the user. First, we take the input video feed of the user and we detect the lips using dlib library and 68 landmark detection library. So we can focus on the lip mouth region, and we then crop those region and we feed them to the model we have implemented. In the model, actually, there's no standard model architecture for lip reading, as this is a complex task in the deep learning world. So first we have to do is that we have to extract the features of the sequence of images, and then we feed those features to the backbone network. Through the backbone network, the model can identify the patterns, and it can predict which word the user tries to speak. So here you can see the sequence diagram and the sample dataset we have gathered for this model. And the second component is sign language detection system, as there are many sign language detection systems in the world, but most of them are for the English sign language. But for single language, it's really limited. In Sri Lanka, actually, we only have 12 sign language translators, and out of those 12, 6 are resides in Colombo, which is our main city. So when you are going to our villages and when we are going to the rural areas, there's no facility to learn a sign language for the ordinary people. So in the system, we implemented a sign language detection system as well as a AI assisted sign language platform. There people can follow different learning paths, and it's an interactive environment. So people can try out different activities, and feedback is generated through through our deep learning models and displayed to the user. So user can evaluate himself, so he can learn sign language as he loves. And the third one is audio to miming language. Actually, this generates a 3D avatar with lip synchronization with singular text transcripts based on the voice of the user. For this, actually, we used a 3D model which was pre-rendered using Blender, and libraries like 3JS were used to animate the model. So when someone speaks, the models detect, translate those voice into the text, and the 3D model get lip synchronized. So the other people who are in the meeting can see that 3D model. So when we're talking about the results, the first one is, as I said, there was no lip reading datasets for single language. So we have to build a foundational dataset for the single language. If you know that single language contains 40 segmental phonemes, but when it compares with the Visim alphabet, there are 15 Visim groups. So same Visim represents many phonemes, and sometimes the other way around. So it's harder to, if we take this based on character level, it's harder to identify. So as I said, there are only limited number of Visim groups. So we choose to go for the word level. In the word level, we recorded some set of people saying predetermined singular words multiple times, and with a custom-made Python application. So in that Python application, we were detecting the mouth region, and we were cropping every frame to a constant rate into 112 into 160 pixel size, and we just applied the filter so that model can easily understand the patterns of the lip sequence. And also after the dataset creation, as I said, there are no standard architecture for the lip reading, so we just have to experiment with different model architectures. So for the front-end network, we experimented with ResNet, MobileNet, time distributed 2D CNN and 3D CNN. And for the backbone network, we tried a greater recurrent unit, and also long short-term memory, and also 3D CNA. So here's the graph. Actually, we got after the model training. So here you can see for the front-end network, the model which perform in its best rate is 3D CNN, since our dataset consists of consistent video clips with 44 frames. Actually, the architectures like LSTM and was much more complex. So we just needed a much less complex architecture. So here you can see the 3D CNN performs at a good level. So also ResNet and MobileNet also performs at a good level, but the MobileNet actually shows some kind of overfitting, since the MobileNet architecture is somewhat little lightly complex, and it just need much less amount of computing power rather than the other models. So finally we got that the model who is performing best is 3D CNN for the front-end network, and also for the back-end network, it was verified that GRU or greater recurrent unit is performing at optimum level than LSTM. So the conclusion is we try to effectively use AI to bridge the communication gap. As I said, that this is a huge problem, and we can use the developed deep learning models and artificial intelligence to solve this issue. And we use 3 components collectively aim to facilitate seamless communication, so the people with speaking disabilities does not feel any barriers with communicating with others. So all the people can communicate seamlessly. And we try to raise the voice of deaf-mute community throughout the world. Also, we hope to extend or expand the system to support other locals too. Currently, we are only supporting single language and for the single speaking community. So that's the conclusion. And if you have any question, you can ask.
Thanks, Kavindra, for your very good presentation. Now, I have one question about the data set. You created your own data set. Is it right?
Yeah,
Yes, very good. So, how many participants were there? And what was the
actually,
size of the data set?
yeah, there was about 200 participants. Actually, it's kind of a foundational data set. We know that lip reading is a complex task. So our data set contained about more than 2000 videos, but comparing to other publicly available data sets, it's much smaller data set. So we need to actually expand this data set, but with the limited resources we had, we just did it as like a prototype.
Okay. And what is the reason what is the reason why mobile net is giving the best result other than that?
Sorry?
Why mobile net is giving the best result in accuracy as far as accuracy and loss is concerned? It is giving the best accuracy with minimum loss. Mobile net. What was the reason for that?
Yeah, actually, the best performing network was the 3D CNN, but mobile network was also performing at a good level, since mobile net is a less complex model and it just need less number of computational power. So, but 3D CNN just it's not a pre-trained model, so 3D CNN captures the patterns from our data set by itself. So it was performing well than the mobile net.
Okay, thank you very much.
Thank you very much. Have a nice day.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Mariam with the paper titled Scene and Aerial Image Classification Based on Advanced Deep Learning Technique. Ma'am, if you're here, then you may start with your presentation.
Hello, am I audible?
Yes, ma'am.
Can I share my screen?
Sure, ma'am. Please go ahead. I'll just exit once.
Hello, everybody. First of all, I would like to thank the organizers of this conference and extend a warm welcome to all the listeners to this international collaboration. The topic of today's research or presentation is scene and aerial image classification based on advanced deep learning techniques. I would like to introduce the authors first. Me, Mariam Mahmood, will be the presenter of this research. I'm a PhD scholar at National University of Science and Technology, Pakistan, currently working as a lecturer at Namal University, Pakistan. My co-authors are Dr. Farhan Hussain and Engineer Asad Jas. My other research details are mentioned in the slide below. The agenda of this presentation will be as shown in this slide. I would start with the introduction, moving towards the methods, tools, and techniques involved in this research. Then there would be some experimentation details. I'll discuss some of the results compared with published literature, and there will be a conclusion section at the end. Starting with the introduction of this topic, we know that classifying scene and aerial imagery is a critical component in applications such as lane use, lane cover, lane mapping, agricultures, environmental monitoring, urban planning, disaster management, and remote sensing technologies. Numerous existing models leverage convolutional neural networks for classification, but they often involve deep design with vast number of parameters and require extensive computational power in prolonged training periods. This research introduces a refined strategy employing a pre-trained efficient network framework. A transfer learning offers a convincing solution to these challenges by leveraging pre-trained models trained on larger image datasets like ImageNet that has around 10,000 images, and then fine-tune them on target tasks with limited label data. In 2019, EfficientNet models came into existence. These models are trained on larger dataset, as I said earlier, that are around that like ImageNet, and they have now multiple variants starting from B0 to B7. The method used to perform this experimentation was EfficientNet V0 model was used as a base model, where multiple tweakings in the layers and hyperparameter after performing hyperparameter training, we were able to get the better results. The tool used for this experimentation was MATLAB. We have used a 2020 version of MATLAB for this experimentation. In order to understand the process of classification, there is a need to know about transfer learning first. This process of transfer learning basically starts with inputting data in the form of images to a pre-trained or model, like in this experimental EfficientNet V0 was used as a base model. The last 3 layers were removed from this base model, and 3 new layers were added, like fully connected layer 1000, softmax layer, and classification layers were added. Hyperparameter were tuned as per the need of the results, and some minor tweaking with the layers were performed, and the model was trained at the ratio of 70:30, while 70% data was used for testing and 30% was used for training. And then eventually we were able to receive the images in a classified form. In order to proceed, there is an image of a pre-trained and fine-tuned EfficientNet model, and this flowchart basically explains the image pixel values of this model. When convolutional neural networks were developed, they were scaled at a fixed resource cost. These networks are scaled up to later to achieve better accuracies when more resources were available. If we talk about ResNet 18, we can scale it up to 200 layers by just adding more layer to the original base model. In most of this situation, this scaling techniques was quite helpful for providing us better accuracy on most benchmark data sets. But the conventional techniques of model scaling were very random. Some models were scaled depth-wise, some were scaled width-wise, while some model simply works better by achieving by getting larger resolution images to get the better results. But this EfficientNet model works on the technique of compound scaling, compound coefficient scaling. It's a simple but effective manner. It performs better results. Instead of randomly scaling up width, depth, or resolution wise, compound scaling uniformly scales each dimension with a certain fixed number of scaled parameters. Here you can see MB convolutional layer. This basically stands for mobile inverted bottleneck convolution. This block is basically the key component of EfficientNet architecture, which is designed to enhance performance and efficiency using lesser resources and convolutional neural networks. Moving toward the inverted bottleneck, unlike other traditional bottleneck layers, this reduces the number of channels initially before applying convolutional functions. And then this inverted bottleneck first basically expands the number of channels and then reduces them. This helps in capturing more feature with fewer number of computational resources I discussed earlier. And this model has basically 7 such blocks of MB convolutional layers, which were able to perform a task of compound scaling in order to get desired layers that can help us achieve better accuracy results using lesser computational resources with lesser number of parameters, and of course, and lesser training time. There are 3 different data sets were used to perform this experimentation. First was MSRC, basically Microsoft Research Cambridge. It is called Microsoft Research Cambridge dataset. It's the most popular benchmark dataset for semantic images segmentation. It was created by Microsoft Research Cambridge team, and it contains images from outdoor scenes. It has around 12 different labels of different categories and around 591 total of images. The second dataset is UCM dataset that was widely used in remote sensing researches, particularly for evaluating performance of machine learning and data learning models for use of land use classification tasks. It has around 21 different labels and 100 images per class, around 2100 total images. While third dataset is CDWHU dataset, it has around 2400 total images and 12 distinct scene categories. This is the most crucial or important slide of this research, where we experimentation details are discussed. This model was trained for 30 epochs, and you all know that learning rate is the most crucial component of any classification task, and piecewise learning rate was performing better. So we have used this basically learning rate scheduler. Training testing data ratio was kept 70:30. Hyperparameter were tuned at weight and biases both were set to 20 initially, and stochastic gradient descent momentum optimizer was used to for optimization task. It basically helps to remove the problem of gradient descent. Similarly, initial learning rates were kept as 0.0001, which was very small, and drop rate was initially kept as 0.1. Using these experimentation details, we were able to achieve the accuracy of 87.68% using dataset UCM on this proposed method, whereas MSRC version 2 is giving accuracy of about 89.78%. CDWHU dataset is giving accuracy of about 89.44%. We have compared these results with the already published literature, and we were able to find these basically results. Here you can see that MSRC version 2 is performing better using proposed model, whereas other researches available in the literature were giving results of about 76.90 to 86.01% in the range of this. Similarly, you can see that this proposed model is performing better than the published literature results. Moving toward the second dataset that was CDWHU, you can see that proposed model gives the accuracy of about 89.44%, whereas other researchers claim that LXNet, VGG19, and VGG16 are giving the accuracies of about 86.52 to 88.04% respectively. Similarly, moving toward the third and the last dataset, that is UCM. UCM is basically also performing better using proposed model that is giving the accuracy of about 87.68%, whereas LXNet, VGG19, and VGG16 and different researchers claim that they have achieved the accuracy of about 79.76 to 83.81%. Here to conclude this research, it won't be wrong to claim that efficient net model is best suited model for and performs better for remote sensing images. And by performing minor tweaking and weight adjusting, we were able to achieve quite reasonably better accuracies. And we have trained this model for only 30 epochs initially, as we have very limited computational resources, and we were able to achieve reasonably good classification results, accuracies in the form of accuracy that was about 89.78%. To conclude this research, it won't be wrong to say that by training the model for more epochs, we can achieve better accuracy, especially for remote sensing images, and they have high demand in areas like lane use, lane cover, and other areas discussed initially. And that's all about my side. If you have any questions, please feel free to ask.
Thank you, Maria, for your presentation. I have two questions. First question I want to ask, what Shri makes better than other?
Sir, give me
what are the characteristics of Shri that makes it better?
Sir, can you please repeat?
You are telling that Shri is providing better result, or you can say best result as far as other two model is concerned. So what makes Shri best?
Sir, basically Shri is a data set that has sir, MSRC version 2 is giving better results. Dataset is giving better results using efficient net base model by performing minor tweaking on it. Whereas CDWHU dataset is also performing quite better as compared to when other techniques were used to classify the images of Siri dataset. I claim that our model efficient net B0 by performing minor tweaking is giving better results on CDWHU dataset.
Okay, so you are telling that Siri dataset is more better than other dataset, and it's a complete dataset. Have you found any problem in dataset?
Sir, no. Remote sensing datasets are quite easily available now.
Okay, so have you pre-processed it? Have you found any problem there?
Yeah, they are mostly refined, but we have pre-processed it, removed the extra data images from the sets to get the optimal results.
Okay, so in which language you did that implementation?
So MATLAB, I have used Python.
Okay, okay. Thank you.
You're welcome, sir.
Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter S. Senthil Kumar with the paper titled Securing the Chain, a Comprehensive Review of Blockchain Security Fundamentals and Challenges. So if you're ready, then you may start with your presentation. Sir Senthil? Seems we do not have him. The next presenter, DB, with the paper titled E-Midwife, Empowering Mothers with Smart Personalized Support. So if you're ready, then you may start with the presentation.
Yeah, sure. So am I audible?
Yes, sir, you're audible.
All right. So is the presentation visible?
Yes, sir, it is visible.
All right. So hi everyone. So thank you for giving us the opportunity to present our research project with WS4. Today I'm excited to share our work on e-midwife, empowering mothers with smart personalized support. So we chose this topic to address the significant gap in maternal care that many pregnant women face. So according to the World Health Organization, a lack of adequate maternal care can lead to negative outcomes for both the mother and the infant. So even in countries with robust maternal care systems, some women still face significant challenges due to various factors such as access to healthcare, social support, and personalized circumstances. So our mobile application, eBeamWife, aims to support pregnant women by addressing four key problems without providing direct treatments or medications. Instead, we offer support and guidance in the following areas. So first one is overcoming the lack of maternal care. Second, identifying alarming health conditions through skin diseases. Efficiently managing maternal health risk in postnatal and antenatal stages. Providing social support during the antenatal and postnatal stages. Effectively addressing postpartum depression. So let's dive deeper into these components to understand how our application works and impact it can have. So first, early intervention of skin conditions. Skin condition during pregnancy can sometimes be overlooked as they might seem minor. However, these conditions can be indicative of some serious underlying issues that could affect both the mother and the baby. So early detection and intervention are crucial. To address this, we developed a model to detect the predict skin related diseases. We categorize these conditions into three classes. Each has 1500 2000 images. Our data set was extensive, and these data set was collected. Some of these data set were collected from Kaggle, and others are built from scratch from contacted uh, so uh, and we trained our model using two algorithms: Inception ResNet version 2 and MobileNet version 2. So after thorough evaluation based on accuracy, validation, accuracy, pressures, and F1 score, and test recall, we chose Inception ResNet version 2 for its superior performance. Sorry, is the presentation slides visible? Hello. All right.
Yes,
Yes, it is
sir.
visible. Yes, yes,
All
yes.
right. Yeah, sure.
Continue,
Yes,
please.
sir.
So the application now includes application includes 3D models for self-examination, allowing mothers to monitor additional symptoms and consult with partnered dermatologists for further care. So these features empower mothers to take charge of their health and seek timely advice if needed. So these are the user interfaces, and the second one is identify maternal risk and exercise suggestions. Managing maternal health risk during the antenatal and postnatal stages is critical for the well-being of both mother and the baby. So our application uses an IoT device to monitor key health parameters such as temperature, blood oxygen level, heart rate, and many others. So these parameters are then analyzed using a trained model to predict maternal risk, categorizing it as high, medium, and low. So this maternal risk dataset was uh, found in Kaggle, and based on the risk category, we suggest personalized exercise plans. The application closely monitors the parameters taken exceeds and in a certain threshold, the exercise is automatically stopped to ensure the mother's safety, as you can see here. So the so our data set for this component was sourced from Kaggle and contains about 1,500 data rows. And also we evaluated several algorithms, including decision tree, random forest, XGBoost before selecting a cat boost for its superior performance. Additionally, we use OpenCVT to monitor the mother's exercise from through a front-facing video feed, ensuring that exercises are performed correctly and safely. So the next, these are the using devices. So this next is a detecting stress relief gaming levels with music suggestion. So for this research, so for this, our focus is on self-help, especially through relaxing activities like music, walking, gamification, and reading. So the e-midwife app utilizes the Edinburgh Postnatal Depression (EBDS) questionnaire to mention uh, postpartum depression levels in new mothers. Based on the results, the app delivers personalized recommendation for stress-reducing games and music tailored to the mother's preference, age, depression level. Studies have shown that gamification activities significantly elevate the depression symptoms. So here, pregnant women take the quiz about emotional well-being, pregnancy experience, and mental health. The system gathers and manages the response, calculating the mother's stress, depression level, and algorithm then produce results indicating their emotional status. After that, the quiz results serves a training data for a model that predicts the mental health of an expectant woman, recognizing patterns between quiz results and emotional states. So after the using the trained model, the app uh, personalize song suggestions and select appropriate game levels. These recommendations aim to enhance the mother's mental well-being by offering enjoyable stress relieving activities. So after that, we are taking a feedback as the mother interact with the games and music. Their feedback helps to improve our model's accuracy, leading to even more tailored recommendations. So model evaluation, we assessed the app's effectiveness using various machine learning algorithms, decision tree, random forest, k nearest neighbors, support vector machine, and voting classifier. So this is going through a voting classifier. That means it's filtered to the above mentioned models. The accuracy scores were impressive. So with SVM achieving the highest at 84. So, but all models perform well, indicating robust predictive capabilities. So the next component is emotional support and risk keyword identification, chatbot. So here the chatbot provides emotional support and identifies risk-related keywords in conversations. So this system is built on careful collected data with over 3,000 entries. Each entry includes health-related symptom prompts, imported terms from these symptoms, risk levels, high or no risk. So, and numerical values showing the severity of importance of the prompt. The dataset was created with the help of external supervisor and health experts to ensure its accuracy and relevance. So the deep learning model that powers the chatbot uses framework like TensorFlow, PyTorch. The model likely uses recurrent neural networks or transformer models like BERT, which are good understanding that predict sequence in text. The dataset was divided into training and validation sets to help the model learn well and the performance accurately. Uh, Metrics like accuracy, pressures, recall, and F1 score. So we use to evaluate how well the model performs. The chatbot uses these advanced algorithms to analyze conversations, detect emotional undertones, and identify risk-related keywords. This helps mothers express their emotions and get timely help if needed. So if a risk keyword is detected in the conversation, the model analyzes it to determine the risk level for high risk terms like signs of severe complications such as health, self-harm, severe bleeding, severe headache, and back pain. So those are the examples. The system sends an SMS alert to the verified family member. So this ensures that serious health issues get immediate attention and intervention care during pregnancy and postpartum. So this is the model performance, and this is a system diagram. So I'll tell about the commercialization strategy. To ensure Wignify reaches as many women as possible, we have a robust commercialization strategy. We plan to partner with healthcare providers, maternity clinics, and hospital to integrate e-midwife into existing maternal care programs. By collaborating with these institutions, we can offer a midwife as an additional resource to expectant mothers. So for individual users, Eminify will be available on major app stores with premium model. Basic features with will be free, and while advanced features and personalized consultations will be available through subscriptions plan. So limitations here is despite its potential Eminify can limitation that need to be addressed. One of the primary challenges is ensuring accuracy and reliability of our models, especially in diverse population and varying health profiles. Continuous updates and retraining the models with new data will be essential to maintain high address. So to conclude, we believe that e-Binware has the potential to make significant positive impact on maternal health. Our goal is to provide accessible, reliable, and effective support for pregnant women, ensuring a healthier and happier journey to motherhood. So thank you for your attention. Is there any questions?
If anybody has question, please ask.
Thank you, sir. I'd once again like to ask for presenter Senthil. So if you're ready, then you may start with the presentation. Sir Senthil Kumar. So if you're having trouble with the PPT, then you can send it to me in the chat box and then we can display it for you. Okay. So the PPT is visible, but you're not exactly audible.
Is an immutable blockchain technology has received a lot of attention in recent years. However, the widespread of this blockchain, this paper is based on the attacks uh, alongside an existing mitigation security solution like smart contract auditing and methods and and arrangements and cryptography are talked this paper. So what is the security difficulty is 51% attack when single entity group of blockchain network computing.
Like you stop sharing your screen, and if there's any technical issue, then you can write it to us in the chat box. So your voice isn't audible. You are on mute right now. You are muted currently. We cannot hear you.
Privacy and confidentiality, so addresses the privacy enhancing technologies, as zero knowledge proof and ring signatures to preserve transactional privacy. Challenges include achieving a balance between privacy and transparency, scalability, and limitations of PETs and regulatory and anonymity. So this literature survey network security analysis, network layer, including service eclipse attacks and similar attacks. So the challenges include mitigating network level attacks while maintaining decentralization and peer-to-peer community. So regulatory compliance, regulatory challenges and compliance requirements for blockchains, including anti-money laundering and you know your customer KYC regulations. Challenging include achieving regulatory clarity, navigating use differences, and balancing privacy and transparency. So, this blockchain forward structures are facing security like civil assault, savvy contractness, arrangements in corporate upgraded agreement systems, high-level cryptography, and agreement alliances in finance, production network, medical care, and government future viable ramifications and safety efforts. Coordinated development are critical for sustaining blockchain environments. So this blockchain security address arising dangers and guarantee trust in blockchain innovation. So
So it seems you have a network issue. Could you please try to resolve it and try it once again?
Oh, no, my screen visible, ma'am.
Yes, sir, it is visible. So, Senthil, while you try to resolve the issue on your side, we can take up the next presenter.
Yes, ma'am.
Please try to resolve your issue. We'll be taking up the next presenter, and then you can go again.
Yes, ma'am. Yes, ma'am.
Okay.
Thank you.
We'll be proceeding with the first presenter, Sir John, with the paper titled Artificial Intelligence for Decision Making in Maritime Activities. So if you are ready, then you may go ahead. Sir John? Do we have him here in the meeting?
Yeah, I'm
Yeah,
here.
please go ahead.
Just give me 2 minutes because I have some issues here, but just 2 minutes, please.
Sure, sure.
I think you are seeing my screen.
Yes, sir, it is visible. Please go
Okay,
ahead.
yes. Yeah. So we have a just to give you an idea. We have a research we started 2 years ago, and the research is based on collecting data from the two seas that we have here in Colombia. So we collect the data based on some sensors which are placed on the seas. We have two seas in Colombia. And those sensors collect data related to, for instance, to precipitation, related to the temperature, the current speed of the wind, and so on. So what we wanted to do was to collect all data, and once the data is collected by the application, which is called Navega Seguro, this application is a mobile application, and you can download from Apple Store or Play Store. And you can, if you are going to do a kind of activity on the sea, like fishing or like other activities, you can download the application, and based on this, you can make some informed decisions. So that's the main objective of the project. So based on this, you can see here that this is one of the screen of our current application, where depending on where you are, you can click on the application, and then you can get the data that I have mentioned already. So based on this, just give me a second. Sorry, because it is, I couldn't get I have an issue with the presentation in English, but based on this, you can, what we have done so far was to get the data into the application, and we used artificial intelligence to do some calculations, to do some computing calculations to define whether you can go to the sea and go and do some activities on the sea based on the variables that I have mentioned that I have mentioned already. So we use fuzzy logic to do so. So based on the data which is collected, we apply some fuzzy logic models, and based on the calculations on the also on the model, the results are presented on the application. So once the information is collected, as I've mentioned, the people that is going to use the application should download the application. They should do a kind of registration on the application. The information is also collected to do some additional activities, and depend on the profile of the people which is using the application, some information is going to be presented. For instance, if the person who has downloaded the application, but the profile is related to doing some tourist activities, like just lay down on the sand in front of the sea. So the information that is going to be presented is like just the temperature, the kind of clothes that should be worn by the people who is just in front of the sea. So we suggest, or the application suggests, based on this, the collected data and the current data, the kind of clothes that that the people should be take to the sea, just to be in front of the sea. But for instance, if the people who is going to do kind of a sport activities on the sea, based on this registration that you are that I'm just presenting, if the profile of the people is just to do some sport activities, so the application is going to present other kind of suggestions, like you should maybe maybe you should do those activities tomorrow, because the speed of the wind is so dangerous for performing activities on the sea. So those kind of suggestions are presented by the application based on the registration profile, because once you are registered, you have to define what kind of activities or what are you going to do on the sea. Just so we perform some kind of tests based on the results. Just give me a second. Are you looking at me at my screen? I'm not sure if I presented.
It's not visible, not visible.
Okay, yeah. So we perform some tests on the results and that the application is giving, and those results and the after we perform some tests using some software, open source software which is available on internet based, and we run some tests based on the performance of the application, based on the user experience of the application. So we perform the different tests to validate the quality of the application and the results that the application presents. So most of the quality tests that we run, they were positive. I mean, they were completely related with the objective of the application. And we found out also a kind of issues that we had to solve in order to provide accurate data to the customers or to the users that are going to use the application. So based on this, what we have done already was to define the action plan to solve those issues that we were facing at that moment. So we found out, for instance, that the temperature that the application were collecting at that moment were not, the temperature wasn't as accurate as it was if we compare to other, maybe other online APIs or online web portals that also provide the same information. So based on this comparison, we found out that yeah, the data had some quality issues, and we had to solve. So based on this, we run again several cases to validate after we correct and we solve the issues that we identified. And after that, we decrease the number of issues, but at the moment we are having some others, and is what we have identified, and we have to do some corrections on the application. That's yeah, the main point. We also run we classified the issues based on a kind of classification model, which is also helping us to identify where the issues are, and where we should concentrate or focus to solve the problems that we are facing right now. So we have at the moment. What I'm presenting to you is on your left-hand side, you will find the initial test, and based on several classifications and on categories, and we face several issues, and after we correct them, and after we run again the tests, we have solved a lot of issues on the application, mainly on the user experience layer, and the data layer, that as I have said already. So at the moment, we solved most of the problems. We identify some others that we didn't realize at the beginning, but those problems are really related to the security layer. So we have to solve maybe in the future is some other issue that we have identified based on these tests that we have applied on the application. So, but we are really happy because we have solved a lot of issues, and we have covered several layers and categories of the user experience best practices, and based on also on the data quality best practices, and we are happy that we have solved most of them. And based on the data, also we have tests with other people just to see and validate if the data that is presented on the application is useful, is helpful, and it helps to perform activities, or maybe just postpone the activities that the people should do maybe tomorrow or next week based on the information which is presented by the application. Just some conclusions based on this. The first conclusion is that most of the issues and the problems that we had at the beginning, mainly with the data, because when we ran the fuzzy logic model, the information that was presented was accurate, wasn't accurate, wasn't also clear when we presented. So based on these improvements that we have done on the application, we have increased the accuracy, we have increased the user experience, we have increased several quality attributes that at the beginning we didn't have it, because we were concentrated on just only on the model. But we realized that the model, of course, is really important. Of course, collecting the data is really important.
I'm really sorry to interrupt you, but I'd like to remind you of the time limit.
Oh yeah, just to finish, we one other conclusion that we end up is that the models are really important, but it's also important how the data is presented, and the accuracy of the data is really also important. That's the end of the work that we have done already. Many thanks for your time.
Thank you,
So
sir.
thank you. Anyone remaining for the presentation?
So there's just one presenter, but we've been told that we can accept his presentation in mail. There would be no effect on publication.
So anybody remaining for the presentation, Ishita?
No, sir, there's just one person remaining, but we have been told that we can accept his presentation in the mail, considering he was
Okay,
having
it's
technical
okay.
issues. But if he's ready,
It's okay.
okay.
Okay, it's okay.
Okay. Sir Senthil, you can share your presentation in mail and there will be no effect on the publication. Uh, we'll be doing the ending of the conference right now. I sincerely thank our authors for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and all the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2024. I'd also like to thank our session chairs for chairing the session. A token to the chair on behalf of Team WS4. and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you, Ishita, for your overall coordination. Thank you.
Yeah, thank you, Ishita.
I'd also like
Ishita,
to thank our session chair, Professor Godfred. Thank you for your valuable presence, sir.
Thank you very much. Thank you very much. Thank you.
Before we end the conference, I'd like to request to everyone to turn on their cameras for a quick snapshot of the virtual conference.
Ishita, please share the photo also. Okay?
Sure, sir. Sure, sir.
Thank you. Thank you.
Thank you, everyone. Stay safe and take care.
Thank you.